Welcome, everyone. Thank you for joining us for tonight's Paleo Indian webinar. I'm Tina Panic from the Avon Library. Thank you for joining us. I'll toss it to Terry from the Historical Society to introduce our guest.
Hello, everyone. On behalf of the Avon Historical Society, the Avon Library, and the Senior Center, and the Planning Committee for this Unearthing History series, I welcome you to the third webinar of our fourth year of educational and informative events covering the Paleo people, animals, and land who lived and worked here 12,500 years ago. For those of you joining us for the first time tonight, welcome. For those who have been with us along this journey, welcome back. We're happy to again be joined by our partners, the Avon Land Trust, the Farmington River Watershed Association, and the Institute for American Indian Studies in Washington, Connecticut. We are pleased to be a third-year recipient of a grant from the Lower Farmington River and Salmon Brook Wild and Scenic Committee so that we can bring you 5 more presentations. Their funding comes from the National Park Service, which recognizes the importance of continuing education of all river matters in this country. The origin of this webinar series is the discovery in 2019 of the Brian D. Jones Paleo Indian site along the Farmington River here in Avon, Connecticut, and the first public presentation of the site in February 2020, which began a deep exploration by us into this incredible time in our world's history. To learn more, please visit the Avon Historical Society's website and the drop-down page for the Brian D. Jones Paleo Indian site. Tonight, we're venturing into yet another part of the exploration of the early times with a presentation on macrobotany, the study of plant remains and pollen data found in many archaeological sites in this region. We know that early people ate what they could find in the land, the animals, and the sea. So thanks to deep scientific analysis of seeds, dried berries, and plant material left at human occupation sites, various methods of analysis can determine what was available at different times over the millennium. In addition, it can tell us what the landscape was like for the humans and the animals that inhabited the area. So to explain all of this in detail, we welcome Katharine Reinhart, project archaeologist and botanical analyst from the Archaeological and Historical Services in Storrs, Connecticut. Kate has been with AHS since 2017. Prior to that, she was in similar positions at Rhodes College in Tennessee, UMass Boston, the Mashantucket Pequot Museum here in Connecticut, and many other places, all focusing on archaeology and cultural resource management. She has a BA in anthropology and sociology from Rhodes College, a master's in historical archaeology from UMass Boston, and while her main focus is on macrobotany from the contact period when the first Europeans came to this region, she has experience and knowledge of early times due to her collaboration and her extensive studies. So Kate, we welcome you, and it's all yours.
Thank you so much for that very warm welcome. And hello, everyone. I am very excited to be here. I'm going to just share my screen very quickly. And hopefully everyone can see this. All right.
Yes,
and
fabulous.
Everything's good? Perfect. So again, as I was talking to them earlier, thank you so much to the folks at the Avon Historical Society, the Avon Free Public Library, and the Avon Senior Center, and the many, many collaborators that they have for keeping this series going so strongly. I'm delighted to be able to be here tonight to share some of my research on Paleo Indian foodways, including a little teensy bit about the Brian D. Jones site here in Connecticut. And we're just going to jump right into a little bit of time travel. So tonight we will be doing a bit of time traveling through the exploration of botanical data recovered from Paleo Indian sites in New England and throughout Eastern North America. Before we begin, there are some terms I'd like to cover and to provide some context regarding what the kind of analysis I do entails. For starters, I am an archaeobotanist by trade, and more specifically, a macrobotanical analyst, meaning I focus on plant remains that are visible to the human eye, but I generally do need a microscope to get into the fine detailed identifications. There are also microbotanical analysts, meaning they study things like pollen and phytoliths. In particular for tonight, I'll be discussing macrobotanical remains such as seeds, plant parts, and wood charcoal, as well as microbotanical remains with a focus on pollen and phytolith evidence. Seeds and wood are the ideal specimens to recover as they allow for radiocarbon dating of sites when they are charred, and depending on the context they are from, provide clear evidence of plants being consumed by people. Some, like nutshell fragments, may be large enough to be recovered while screening on site, while others are small and only recoverable through a type of water screening called flotation, seen here on this slide. Flotation involves gently agitating soil samples from hearths and other cultural features, submerged in specialized screens and buckets that remove smaller soil particles to reveal rocks and small artifacts. This is called the heavy fraction. It allows plant material and other buoyant materials to be skimmed from the water's surface, called the light fraction. As will be discussed during this talk, there are very few sites dating to the Paleo-Indian period with recovered specimens from secure cultural features like hearths and fire pits. So this is very special. On sites like the others throughout Eastern North America, with very little macrobotanical evidence or none at all, pollen and phytoliths are your best bet. Both sets of data can also tell you a lot about past environments, and the pollen that sends many of us into sneezing or coughing fits at certain times of the year offers insights into how warm or cool the weather was during a period. They can indicate how rainy or dry it was, and what kind of trees and plants were growing. Phytoliths are microscopic silica structures produced by some plants and are essentially plant fossils left behind after a plant decays. You can recover them from archaeological soil, as well as from tools and ceramics that may have been used to process or cook plants. Archaeologists investigating Paleo-Indian sites often rely on microbotanical remains, considering the rest of the macros are not easily preserved unless they are charred, waterlogged, or desiccated. So setting the scene a bit. The Paleo-Indian period in New England, as researchers currently understand it, spans roughly 5,000 years of the region's earliest indigenous history. During this period, there were notable shifts in the environment and climate brought about by the retreat of the Laurentide ice sheet, visualized here by this wonderful graphic. The yellow star on this map illustrates the location of southern New England. And if I were piloting an actual time machine with all of us in it, I would set the dial to land us in Connecticut a little over 12,000 years ago, right as Paleo-Indian people were beginning to explore the northeastern United States. By then, Connecticut had been transformed into an ice-free tundra, and in turn made way for coniferous trees like spruce and white pine, as well as aquatic plants. The Bowling and Alarod warming periods, occurring between circa 14,700 and 12,900 BP, prior to the periods I'll be discussing tonight, brought with it an increase in temperature and moisture, making the region habitable for a variety of plant life. As the region's ecosystems continued to become more diverse, the plant and freshwater resources they drew a variety of animals as well as the humans who pursued them. This warmer and wetter period was interrupted around 12,900 years ago by the Younger Dryas, which has been described by climate scientists as the most severe and long-lasting interruption to the warming of our Earth's climate. Global temperatures were reduced to near glacial levels within a decade, and lasted until around 11,700 years ago, with another drastic shift to warmer temperatures and more diverse ecosystems. While the Younger Dryas climactic shift did not affect all regions equally, it still presented a problem for Paleo-Indian peoples, animals, and plants. And for all of you joining me tonight, if you were in that time machine, don't worry, I would take my role as time travel guide very seriously and pack plenty of provisions and weather-appropriate clothing. These shifts in climate heavily affected the resources available during the period, as well as cultural practices. With the onset of the Younger Dryas, indigenous groups began to establish regional and sub-regional cultural traditions, including diversification in projectile point forms among their already highly specialized stone toolkits. Research into the extinction of megafauna like mastodons indicates that Paleo-Indian groups may have adapted their subsistence practices to include medium and small game instead, as well as targeting available plant life. Humans have long been omnivores, and when preservation conditions and archaeological sampling strategies were excellent, evidence pointing toward a diversified diet has been recovered. In his article on climate and culture change from 2001, David Anderson proposed that colder, unpredictable temperatures may have restricted mobility across the landscape somewhat, and in turn, made having extensive knowledge of local and regional plants a critical part of the indigenous life during the period. Later warming periods that occurred after the Younger Dryas, around 11,700 BP, also brought about shifts that came on suddenly and were beneficial for the expansion and supportland of wetland environments and resource-rich woodlands. There have been a number of excellent pollen studies carried out in the Northeast region since the method began to be applied to archaeological contexts. Margaret B. Davis's 1969 work at Rogers Lake in Lyme, Connecticut offers a particularly detailed survey of prior and new, at the time, pollen data. She highlights plants that would have been available during the Paleo-Indian period in the region, as well as insight into those past climates. The oldest soil zone she analyzed revealed that while pollen rates were low during this period, there were a fair amount of sedges and grasses on the landscape with lower rates of tree and shrub pollen, offering supporting evidence of a tundra landscape during early Paleo periods. The next oldest zone, correlating with early/middle Paleo dates, indicated a transition from grasses to trees like spruce and poplar. The next two zones, which represent the region's middle and late Paleo-Indian periods, demonstrate an even more dramatic rise in mixed forest systems, indicative of further climactic warming. While not a sign of tropical breezes rolling through New England, these increases offered the opportunity for more varied forest ecosystems and warmer temperatures, and support the idea of Paleo-Indian people having what may be thought of as their equivalent of our supermarkets right at their fingertips. At the Brian D. Jones site, we are extremely fortunate in that we have recovered a wide array of macrobotanical specimens from cultural features. This diverse assemblage reflects the consumption of fruits, nuts, and weedy plants, as well as wood charcoal species that illustrate the presence of a mixed forest ecosystem. The plant and tree species identified here were recovered from a wide range of cultural features, many of which were radiocarbon dated and reflect multiple occupation periods. One of the most notable species identified at this site are the multitude of water lily seeds recovered from my analysis of light fractions. Ethnobotanical research conducted by Lucinda McWeeny has illustrated these plants may have been a valuable food source, with the floral disc and seeds being ground into flour and seeds roasted to be consumed. Final analysis indicates that the plant actually may have been being processed there. And of the 74 seeds I identified from BDJ samples, this is rather significant considering they've also been recovered in charred condition from other sites such as the Jefferson site in New Hampshire, nearby Pequot cedar swamp sites, and others. And part of my recent research on the BDJ plant remains has involved comparing the species there to the region's pollen data. Aside from much of this data confirming what pollen has to tell us, it also helps us expand our understanding of Paleo period ecosystems in New England and gets us that much closer to connecting those plants to early Native American foodways. Aside from the wealth of available ethnographic data, as well as the Shawnee Minisink site in Pennsylvania, we have very little physical evidence of which plants were being chosen for consumption in that period. Shawnee Minisink is by far one of the best records we have of Paleo-Indian plant consumption outside of BDJ in North America. The excavations were scientifically ahead of their time, and their efforts produced a respectable list of berries, nuts, and weedy seeds that may have been consumed at the site by humans or by the birds and animals they caught. There's also the nearby Templeton site, excavated by Dr. Moeller and Dr. Singer in Washington, Connecticut, which yielded identifiable wood charcoal specimens. The Pequot Cedar Swamp sites, excavated by Dr. Kevin McBride and his colleagues in collaboration with the Mashantucket Pequot tribe in the mid-1980s, recovered plant macrofossil remains from soil cores and cultural contexts, further aiding in solidifying pollen results for the region. Lucinda McWeeny's macrobotanical analysis of the Neil Garrison site in Maine yielded a range of wood charcoal data. And even farther afield is the late Paleo-Indian site, Dust Cave in Alabama, which produced a wide variety of nutshell, weedy plant seeds, and fruit species. A chronological comparison of the plant and wood species recovered at the Paleo-Indian sites discussed in the previous slides offers us a more widespread view of early diets in Eastern North America. The table on this slide makes that comparison, and all species highlighted in green reflect species that are present at different sites and other Paleo-Indian periods. By analyzing such comparisons, there's the opportunity to make connections between temporal and regional similarities and contrasts in the plant species being identified. Again, there's a clear overlap in some cases, such as water lily, hazelnut, goosefoot, grape, acorn, and hickory. It is also clear that Paleo-Indian peoples consumed a wide variety of plants, with some indications for regional variability. This variability may stem from the specific ecosystems being foraged, preferences being passed between and among groups, or climatic differences considering how volatile climate changes were. Aquatic plants like water lily, cattail, and pondweed bring forth the image of resource-rich wetland environments, while nutshells and fruit plants call to mind woodland environments that served as paleo supermarkets. The pollen record, climate data, and the species identified here reflect the many climatic shifts that Paleo-Indian peoples experienced, but they clearly continue to successfully procure foods throughout the region. There is also plenty of overlap in wood species identified at Paleo-Indian sites. Both hardwoods like oaks and softwoods like pine are present throughout these sites. Pine is particularly prevalent throughout these eastern sites and is often considered a pioneer species, meaning that they are species that begin to fill in plains and open areas where larger, older hardwood trees have not yet taken root. The variation in hardwood species is most likely due to environmental factors. And while not included in tonight's presentation, it would be very interesting to compare densities of wood species across these sites. Considering the differences in heat, smoke quality, and burn time between softwoods and hardwoods, it may be possible to investigate occupation lengths and intensities. Comparisons of the wood species recovered at these sites in comparison to the pollen record presented by Davis also presents us with an avenue to explore wood fuel choice and connections between climate and environment in the Paleo-Indian period. Much of what we know comes from the handful of sites that have been excavated in the region, including the 7 identified here in Connecticut, with additional insight coming from excavated sites located throughout Eastern North America. However, aside from these sites and extrapolations made from pollen, most sites lack a healthy amount of plant remains. Researchers interested in the study of plant consumption during the Paleo-Indian period have attributed this lack of botanical data to preservation issues, as well as a lack of soil sampling strategies during excavations that were conducted before we began using more scientific methods. Researchers studying the Paleo-Indian period started engaging with the idea of plants comprising a significant portion of the early indigenous diet as early as the 1970s, and additional data has allowed us to start exploring the choices these groups were making as they consumed plants. In large part, it has become clear that paleo groups were selecting plant resources that were not only readily available, but also offered necessary vitamins and nutrients that meat-based subsistence strategies would not be able to fulfill. Fruits like blackberry, grape, strawberry, hackberry, and blueberry are high in vitamin C, carbohydrates, and other dietary necessities. While some of us today might find it intriguing that back then they were taking their nutrition into account and not just foraging what they could without the help of ingredient lists or doctor's advice, it is quite easy to understand how and why these plants became added to the list of things that they deemed good to eat. Some of these botanical discoveries may have been added through observation of animals eating them, or perhaps even prior experience with similar looking plant species from their travels throughout the region, helping them to mark certain foods for consumption. As omnivores, it is in our nature to be curious about expanding our options, and it is likely that, depending on the plant, if there was a positive experience tied to it, they would continue to forage for that plant to provide for themselves and the rest of their group. And funnily enough, this next slide was inspired by Tina here at the Avon Free Public Library. She sent me a wonderful question about the strawberry at BDJ. And specifically, she wanted to know, what would the strawberries represented by the seed identified there have tasted like? And to be honest, as I told her, my best guess would be something akin to the wild strawberries produced on today's landscape. You see, the strawberries we find in our grocery stores today are largely a product of hybridization of the plant. As mentioned earlier, I studied the 16th and 17th century European efforts to blend American species like strawberries with European varieties for my recently completed master's thesis. One of the more interesting pieces of information I learned that would make sense to mention in this presentation is that European colonists found native strawberry species to be much tastier than the varieties that grew wild or were cultivated in their homeland. Keep in mind, our idea of sweet is different from what theirs was. So don't expect to be turned off from our modern modified varieties anytime soon. However, I encourage those of you who are avid gardeners or foragers to take a bite out of a late season wild or even cultivated strawberry during the early morning or on a cold day. Farmers and produce experts have attributed cold to making strawberries sweeter and crisper, and based on available climate data, this might be the closest you'll get to sharing taste buds with a Paleo-Indian person. While wild strawberries and other fruits recovered from the sites I've mentioned are not as sweet and plump as those we buy at the grocery store today, they very well may have been added to the Paleo-Indian diet for their tasty qualities in addition to their nutritional value. It is important to note that not all plant remains, even charred specimens, are directly related to human consumption. For example, the pondweed identified at BDJ and the Jefferson site in New Hampshire is not a plant that shows up in ethnographic literature as a food or medicine. Aside from being accidentally introduced, the most likely scenario is that seeds and plant parts from such species were deposited during the activities associated with processing birds and animals that ate them before being caught. In fact, there's a fair amount of research dedicated to the study of bird migration patterns in connection with Paleo-Indian subsistence strategies. Stuart Fidel wrote an excellent piece on this, and there's an article authored by the late Dina Dinkhouse and Victoria Jacobson, exploring this concept well and proposing the Greater Atlantic Flyway along the path that drew indigenous groups to the edge of the Laurentide ice sheet. These edges along the ice sheet would have provided resource-rich woodland, wetland, and tundra environments, which were attractive for birds as well as their human counterparts. There are also plants such as goosefoot, a relative of the quinoa sold in our stores today, and other weedy plants listed here that have been tentatively identified as non-foods for Paleo-Indian groups when being discussed in recent literature. Some archaeologists studying these remains have given nods to the fact that many of these species, such as Chenopodium or goosefoot, came to be consumed by indigenous peoples during more recent periods. And by recent, I mean archaic, so not too recent. And personally, I fall within the camp of attributing such plants to the food category because I think that there is evidence from later periods, and it is possible. The growing and harvesting season for the plants recovered from these sites would have been about a month shorter than the growing season we are currently accustomed to. Fluctuations in temperature would have played heavily into the production of seeds, nuts, and berries Paleo-Indian peoples would have foraged for. And as can be seen here on this slide, many of the species being discussed here tonight would have offered harvestable material in the late summer and early fall months. Hickory nuts, hazelnuts, acorns, and black walnut would have been available for longer, but the remainder of berries and weedy plants would not be found fresh the remainder of the year. With such a short growing season in the mix, and if Anderson's hypothesis that mobility across large swaths of the landscape may have been slightly hindered by climate fluctuations, these groups may have incorporated preservation techniques like drying or cooking over their hearths to be able to have plant-based vitamins and nutrients throughout the much colder months. Alternatively, and more in line with traditional views of Paleo-Indian peoples, they may have refocused their attention on hunting or followed routes leading them southward as the winter took hold of the northern regions of America. Preservation of plants for later consumption is traditionally associated with more sedentary or settled groups. However, considering plant products are light options for on-the-go foodstuffs, I personally don't consider it outside of the realm of paleo possibilities. Nuts preserved well for long periods of time on their own, and with the exception of acorns, require little processing. And please, before any of you go foraging for acorns, please remember that in order to consume acorns, if you are feeling inspired, you first need to leach them using hot or cold water to remove tannins so that they are safe for human consumption. Goosefoot seeds, like the ones recovered at BDJ, Dust Cave, and Shawnee Minisink, are rich in fat and protein, but they do require a lot of time and energy to process and to harvest. The factoring in of that added effort required for both acorns and goosefoot places them closer to the category of having been deposited accidentally while someone roasted a bird or other animal, or while disposing of its innards. However, I do not think human consumption or on-the-go storage of these plant products during the Paleo-Indian period is completely out of the realm of possibilities. This especially goes for the sites where they are recovered from, considering the size and proposed intensity of occupations there. While rooted in actions being observed in more modern times, ethnography is an immensely useful tool when investigating pre-contact plant consumption. I often use ethnographic and historical accounts produced by both Indigenous and Euro-American sources, with a very critical lens applied to the Euro-American sources, when investigating Native American archaeobotanical specimens. This type of research is often the closest any of us will get to hopping into a real time machine and interacting with the people in older time periods. For tonight's presentation, I specifically employed Gladys Tantaquidgen's book while determining if there may have been any medicinal uses for plants in these Paleo-Indian period assemblages. Some plants like arrowhead, pokeweed, sumac, and birch had parts that may have been valued for a variety of aches and pains. Tantaquidgen cites pokeweed in particular as being prescribed as part of complex remedies for rheumatism, breast pain, as a stimulant, and an abortive agent. She also mentions it among the list of plants that would have been critically important in the early spring months for the much needed nutrients in its young shoots. Lucinda McWeeney's work found that water lily tubers also have medicinal properties. And other plant parts like cattail root, blackberries, and wild cherry varieties were sought out for specific ailments. For instance, I believe cattail root was for kidney stones. While seeds and wood do not provide direct evidence for these medicinal uses during the period, we may be able to take some liberty in attributing later uses of these species to these groups learning early on to provide medical care to each other as they began to inhabit the New England landscape. Ethnographic research also supplies us with useful data for understanding other uses of plants. Aside from their nutritional and possible medicinal value, cattails provided stalks and leaves, which are useful for weaving into mats, for ground cover, and structure insulation. Pokeweed came to be valued as a purple and black dye in later periods, which may have been noticed early on. And if you are anyone that's out in the woods and you may have sat down on a berry, you will definitely see that dye on your pants. It is very bright. Pine needles, having been recovered from hearth or other cultural contexts at many of the Paleo-Indian sites I've mentioned tonight, as well as on younger sites in the region, may be indicative of their use as tinder for starting fires. As my own work at the Brian D. Jones site and the research being conducted by other botanists and archaeologists at these sites continues, our understandings of the paleo environment and human foodways will continue to evolve. On the part of AHS, we are currently pursuing some more phytolith research with the help of Kaylee Wade at Atlatl Limited in Canada. We hope her analysis will expand the diversity of identified species. I've also been continuing to expand on research I've already conducted for the site and will have more to tell you at a future date. And for current and future sites dating to the period, I hope archaeologists will continue taking soil samples, as much dirt as your budgets will allow, please. There have been major technological advances in the field in recent years as well, and who knows what we'll uncover next. And in conclusion, plant remains are a powerful line of evidence for learning about the past. Plants have played a large role throughout our existence. As much as we've changed them over the thousands of years of our species history, so too have they changed us. They offer us food, medicines, clothing, shelter, and heat even today. For Paleo-Indian groups, they offered dietary necessities and were most likely a major reason that many of these sites were returned a range of radiocarbon dates when dated. Open woodland areas and wetlands, which were the settings for many of these sites, are the equivalent of our modern day grocery stores, especially for people who know what they are looking for and when those plants are available. Native American groups have benefited from masterfully reading the North American landscape and ecosystems throughout it for thousands of years, which should always be taken into account in archaeological research. Finally, and before you all get to ask the questions, I do want to leave you with this rhetorical question. If you were dropped into one of these Paleo-Indian period supermarkets, would you know what you were shopping for? Thank you again to all of our online hosts and to all of you joining us tonight. I also owe a huge thank you to my colleagues at AHS and other sites and doing this important work. And if anyone is curious about any sources that I used for my work tonight, please feel free to reach out. I see a hand.
Fantastic. I do not know why my own hand is raised, but thank you. Thank you, Kate. We will definitely take audience questions. And then while we're asking them, I will unraise my hand. I'm not sure what happened. Zoom is not cooperating for me today, but the first question from the audience is, as a modern mushroom forager, have any researchers found any evidence of the paleo diet, including fungi? Are we looking at the spore record in addition to the pollen record?
So I will be completely honest with you. I do not know anybody that is personally looking at that. However, I have learned through some of my investigations and explorations into the micro stuff that spores are being sought out. So it is very possible that maybe we could get some of that data. I just unfortunately do not have that information.
Okay. All right. And then I wanted to ask what your favorite part of this research process is. Do you have a favorite part of the analysis that you like?
Oh, absolutely. Aside from just loving to learn about all of it, again, my wheelhouse is historic period sites, but getting dipped back into Paleo-Indian period, it really has my brain buzzing. I think I find it the most interesting when there are unexpected species that haven't been found at other sites, like the strawberry. And also, I really find it fascinating when I find overlapping species, because that does point to some trends and patterns. And also, I don't know if anybody knows how big water lily seeds are, but they are rather small. And picking those out of the soil samples was a challenge, and well worth the challenge. We'll say that.
Yeah, fantastic, fantastic. All right, if anyone else from the audience has a question, pop it in the chat or the Q&A. In the meantime, Terry, did you have anything you wanted to
so a couple of things. So macrobotany, as you said, is what you can really kind of see. So is there microbotany, which is things you can't really see, but you know they're there, and you just, what's that about? And what kind of things would that be?
So again, that would be like phytoliths, and those are, again, silica bodies. They're very small, and if I were to pick up a handful of soil from a site, I would not be able to see them. And so they're actually put through certain, depending on the analysis you're doing, certain chemical and technological processes. I believe when I was talking to Kaylee earlier this week about some of the work she'll be doing for us, she was talking about putting samples into a centrifuge to extract the phytoliths. And then she'll put them on a slide and do her counts and see what's there. And a lot of it comes down, that's really more of a burgeoning field still. It's been around for a while, but they're still developing identification protocols. And so it's kind of exciting that it gets to be added to that data. But that and pollen is fabulous for environmental reconstruction. And then there are also starch grains. So think about like the goosefoot, heavy in starch. You may be able to identify that on a tool, even if you don't have it at a site. But again, it would be microscopic, and you'd have to prepare your tools and your soil for that kind of analysis.
That was going to be my next question. Did you find anything on tools or on lithics themselves, on the stones themselves, like for grinding and things like that? Can you get that kind of information off of what what was on it, besides the blood protein that we know was on one piece there, but in the seeds area, what did you find?
So there was a little bit of preliminary phytolith analysis done by Paleo Research, and they found water lily phytoliths on a grinding stone, which may be indicative of them actually processing the tubers. Again, phytoliths, they come from specific parts of the plant. So if you can get them down to the actual part of the plant, aside from just species, you can talk about what they are actually processing and maybe why.
Wow.
But you can definitely get those off of tools. But if there are any professional archaeologists in the audience, please do not wash your tools that you may want to test for that. You need to keep them as they were and in a secure condition as you collect them.
Fascinating.
Wow. And now the questions have started coming in. So this one they're sort of related. They sort of have two halves. Are you able to study the DNA of the seeds? And have you found any evidence of plants that don't grow here anymore?
So I personally cannot do that kind of analysis. I would love to. And I was actually talking to you, Tina, about reconstructing some of the DNA from that. I am about to start a PhD at UConn in the fall, and there are a lot of folks that are doing that kind of research. So I'm hoping to connect with them and learn more about that. But as for macrobotanicals, and if I've encountered anything that's not around anymore, not yet. Okay. Yeah, which, when I started doing the more ancient analyses, I was kind of expecting that. And I was like, oh, it's a whole new world. I can't wait. But it is also interesting of itself that we have many of those species still around today, and it really speaks to the hardiness of those species.
Okay. And the next question is, do you know how far from the site Native Americans would have traveled when foraging? Is there a general radius?
Ooh, and now I'm wishing that I had included the slide that I almost included. There was actually some work done, I believe, by Dan Forrest. And if that person wants to reach out to me, they're more than welcome to have my email address, so I can send them the article. But he did study the mileage between a site and nearby wetlands. And wetlands are really one of the main places you would be going for these resources. Your animals are going to be there, almost all of your plants. And I think it was relatively close, but I can't tell you exact data. And again, I'm sorry I did not include that slide today.
That's fine. Tom, email me. I sent you the Zoom link, and I will connect you with Kate and get you the article that you're asking for. Okay. I think we've gotten through most of these. Any final thoughts for our audience to ponder? Because I'm going to dream of strawberries this evening.
I really urge you to engage with your environment. I know that we are not living in those climactic periods. We're not living as they would have, but it does bring to the forefront even some of our climate challenges that we're experiencing today. There were probably plenty of plants that we would love to have in the future that, if we continue to let climate change happen, may be gone, in much the same way that, natural climate change took away some species for Paleo-Indian period peoples. So I would just take that as a grain of salt. Also consider, in an apocalypse situation, would you be able to identify some of these plants?
Oh, yeah, that's right up your alley.
I love the apocalypse, and I can do some of them, but my mushrooms are not strong. I would have to rely on my friends in the land trust to help me not poison myself. So
Right.
I'd have to make an alliance. It would be very complicated. It would be very political, but we would figure out which mushrooms we could eat. So
Perfect.
We have had these conversations about the apocalypse over many years, so just get ready.
Hey, it only took 4 years to get the strawberry foraging
yeah.
question answered, which is
Right.
fantastic. All right. This has been an absolute delight. Thank you very much for joining us, Kate, and everyone who tuned in tonight. And we hope to see you again soon. You're welcome back anytime.
Thank you.
Yeah.
Thank you,
All
everyone.
right. Thank you, everybody. Bye-bye.